Now let's solve problem number 1.22 from this book. Let me read the problem for you. The velocity of particle moving in positive direction of x-axis. A particle is moving in positive direction of x-axis and its velocity varies as alpha root x. Means velocity is a function of displacement along x-axis. A particle is moving along x-axis and velocity is varying with x-axis, where alpha is a positive constant. Assume that at a moment t equal to 0, at t equal to 0, particle is at x equal to 0. Find the time dependence of velocity and acceleration of particle. They had asked us what is velocity as a function of time, what is acceleration as a function of time. Mean velocity of particle averaged over time that particle takes to cover the first s meters of path. Mean velocity over s meters. This is the problem. देखिए, velocity as a function of displacement, I can always write velocity as dx by dt. Velocity can be written as dx by dt, the rate of change of displacement along x-axis. Since the particle is moving along x-axis, I can rearrange this equation as 1 by root x dx is equal to alpha dt, and this can be integrated on both the sides. Alpha is a constant, integral sign से बाहर रहेगा. At time t equal to 0, x is 0, and at any instant t, it's x. Now, its integration is root x. One by x to the power half or x to the power half. This is x to the power minus 1 by 2. It's x to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 or plus half. Alpha t from 0 to t and this from 0 to x. Or I will say this 2 root x is equal to alpha t, or x is equal to alpha square t square by 4. This is displacement as a function of time. This is displacement as a function of time. Now, we had asked with velocity as a function of time. In order to write velocity as a function of time, I will say velocity is dx by dt. I differentiate it with respect to time. So, this comes out to be alpha square t by 2. This is velocity as a function of time. Acceleration as a function of time. Acceleration is dv by dt. I differentiate this with respect to time, or it's alpha square by 2. The acceleration as a function of time. Now, mean velocity of particle averaged over the time, that is over the time that the particle would take to cover first s meters. अब देखिए, how do we define mean velocity? Mean velocity is defined as integral of v dt upon integral of dt, or this is delta s by delta t. अब फर्स्ट एस मीटर्स ट्रेवल करने में कितना समय लगेगा वह हम निकाल सकते हैं। हम कहते हैं एट टी इक्वल टू 0, x equal to 0, and when x is equal to s, this time would be, इसकी जगह मैं s लिख दूंगा 4s by alpha square, 4s by alpha square and under root of this is the time. Now mean velocity would be given as distance traveled is s minus 0 and time taken is under root of 4s by alpha square minus 0. So this comes out to be alpha by alpha root s by root 4, or you will say this mean velocity is alpha by 2 root s. So this are the answer to the problem. Once again मैं तेजी से प्रॉब्लम कंडीशन और उसके आंसर को तेजी से समझा देता हूं. A particle moving along x-axis where the velocity of particle varies with x-axis according to this function. Initially at t equal to 0 particle is at 0. What is velocity as a function of time? What is acceleration as a function of time? And what is the mean velocity averaged over the first s meters of its travel? This is the problem. First of all, we wrote that velocity could be written as gx by dt because the particle is getting displaced along x-axis, and this gx by dt equal to alpha root x. I had rearranged this differential equation 1 by root x dx equal to alpha dt. I had integrated it on both the sides. This is integration. I put the limits. Limits is at 0, time t equal to 0, displacement is 0. At any time t, x is the displacement. So this is the equation that we get for displacement variation with time. I had differentiated in order to get the velocity. Velocity is gx by dt. हमने इसको differentiate कर दिया. In order to get acceleration, we had differentiated velocity with respect to time. dv by dt is acceleration, and this is acceleration. And mean velocity. Mean velocity is defined. It's denoted like this. It's defined as integral of v dt upon integral dt, or distance upon time. Total distance upon total time over the interval. At t equal to 0, x is 0. When it travels s meters, this would be the time. हमने x की जगह पर s लिख दिया 4s by alpha square और उसका अंडर रूट. दिस इज द टाइम. So mean velocity is distance s minus 0, time is final time minus initial time, and this is the mean velocity. Now, let us solve problem number 1.23 from the book. Let me read problem statement for you. Point moves rectilinearly with deceleration. Decelerating particle की बातचीत हो रही है. Point move rectilinearly with deceleration whose modulus depend on velocity. Its modulus depend on velocity like this. It's a under root of v, where a is a positive constant. A is a positive constant. At the initial moment, the velocity of particle is v naught. At t equal to 0, velocity of particle is v naught. What distance will it traverse before it stops? What time will it take to cover that distance? When it stops, what is that time and what is the distance traveled by the particle? Now, we need to solve this situation. देखिए, a decelerating particle. Let me say acceleration of particle is w and that acceleration is dv by dt, and since that already mentioned it's a decelerating particle, तो इसको मैं negative लिख देता हूं, and this is the moduli of deceleration. So this is the deceleration minus or this is the acceleration minus of a root v. A is a positive constant and acceleration is varying as a function of time. Now, in order to solve this differential equation, let me rearrange 1 by root v dv is equal to minus a dt. I rearrange this differential equation in this manner. I integrate it 1 by root v dv is equal to minus a integral of dt. I integrated it on both the sides. Now I identify and put the limits. At t equal to 0, velocity of particle is v naught, and at any time t, velocity is v. Integration of this function is 2 root v from v naught to v minus a integral of dt is t from 0 to t. Or I will write v root v minus root of v naught is equal to minus at by 2. Or velocity as a function of time would be v naught minus at by 2 whole square. This is velocity as a function of time, or I may also write it as v is equal to v naught minus a root of v naught into t plus a square t square by 4. This is velocity as a function of time. Now, I put the condition when it stops. When it stops, velocity of particle would be 0. So, when the particle is stopped, velocity is 0 and that time is t naught. Let us say that time is t naught. I substitute this condition here. Velocity is 0. This is root of v naught minus a t naught by 2, or that time t naught would be equal to 2 root of v naught by a. This is the time when it stops. Now, the next part of the same question is the distance it travels before it stops. In order to determine it, for this velocity I will write ds by dt. Velocity की जगह मैं ds by dt लिख देता हूँ. ds by dt is v naught minus a root of v naught into t plus a square t square by 4. I rearrange this differential equation. ds equal to v naught dt minus a root of v naught t dt plus a square by 4 t square dt. I integrate it on both the sides. मैं इसे इंटीग्रेट कर देता हूं, कांस्टेंट को इंटीग्रल से बाहर लिखूंगा, एंड देन आई पुट द लिमिट्स एज वेल. व्हेन इट स्टॉप्स 0 टाइम पर डिस्टेंस इज 0, initially 0 time per distance is 0, and when it stops the distance traveled is, let us say, s, and time is t naught. So this becomes s is equal to v naught t naught minus a root of v naught into t naught square by 2 plus a square by 4 into t naught cube by 3. Now I substitute the values for t naught. This is the t naught. मैं यह वैल्यू सब्स्टिट्यूट कर देता हूं. v naught into t naught की जगह 2 root of v naught by a minus a root of v naught into t naught square by 2 की जगह मैं लिखूंगा this is 4 v naught by a square plus a naught square by 4 into t naught cube. t naught cube की जगह 8 v naught into root of v naught by 2 into a cube. Now, in order to calculate distance, v root of v naught मुझे हर जगह पर दिख रहा है, v root of v naught मुझको हर जगह पर दिख रहा है, अपॉन a भी मुझे हर जगह पर दिख रहा है. इस तरह से इधर एक a बचेगा, इस तरह से इधर भी एक a बचेगा. v naught by v naught डायमेंशनली उसको सही होना ही चाहिए. और ब्रैकेट के अंदर देखिएगा 2 minus 2, this is 2 minus 2 plus 8 by here I think एक 3 का फैक्टर और है into 3 into this is, just check it, sorry, into 3 this is 2 by 3, this 2 get cancelled. So distance before it stops comes out to be 2 by 3 v naught to the power 2 by 3 upon a. This is the distance traversed by the particle before it stops. मैं एक और बार पूरे प्रॉब्लम को समझाता हूं. करने के तरीके को, प्रॉब्लम क्या दिया हुआ था, अ डिसिलरेटिंग पार्टिकल ट्रेवलिंग in a line, a decelerating particle where moduli of deceleration is a root v, means particle decelerates and the function of deceleration is given in terms of velocity. Here a is a positive constant. Initially particle is moving its velocity v naught. When it stops, what is the distance traveled before it and what is the time? मैंने कहा acceleration is equal to dv by dt, and that acceleration must be negative because it's a decelerating, and moduli of that acceleration is a root v. For dv by dt equal to minus a root v, I rearrange the differential equation. 1 by root v dv is equal to a minus a dt. I integrated it on both the sides. I substituted the limits. At time t equal to 0 velocity is v naught, at time t equal to t velocity is v. मैंने इसे इंटीग्रेट कर दिया. 2 root v, limits like this, minus a t limits. I substituted the limits and then we get the velocity function with time. This is the velocity function with time. वी नॉट इधर गया, v इक्वल टू अंडर रूट ऑफ वी नॉट माइनस at/2 होल स्क्वायर. दिस इज द वेलोसिटी फंक्शन विद टाइम. मैंने इसे एक्सपांड कर दिया. दिस इज द वेलोसिटी फंक्शन विद टाइम. मुझे आगे वेलोसिटी के इस फंक्शन की भी आवश्यकता लग रही है और इसकी भी आवश्यकता लग रही है. नाउ व्हेन इट स्टॉप्स, इस पार्टिकल के स्टॉप होने की कंडीशन क्या होगी? द वेलोसिटी मस्ट बिकम जीरो और रूट वी मस्ट बिकम जीरो. रूट वी की भी वैल्यू जीरो हो जानी चाहिए. इन दैट टाइम लेट अस से दैट इज टी नॉट. मैंने इस कंडीशन को इधर लगा दिया, रूट वी को जीरो कह दिया. जीरो इज इक्वल टू रूट वी नॉट माइनस ए टी नॉट बाय 2. दिस थिंग मस्ट बी जीरो एंड आई सॉल्व्ड इट. और इस तरह से मुझको है टाइम की वैल्यू मिल गई. टाइम टी नॉट इज 2 रूट वी नॉट बाय ए. इस टाइम पर पार्टिकल स्टॉप, that particle would stop, means the velocity of the particle would become zero. Now velocity is gs by dt. Velocity is gs by dt is equal to this function, this complete function. Velocity is a function of time. I rearranged and I got displacement function with time. This is the displacement function with time. मैंने 0 से t नॉट टाइम के लिए डिस्प्लेसमेंट के लिए सॉल्व कर लिया. Solve it carefully and you'll get the answer. Please check it.